Alright, this is in reference to the above problem. It says an unmarked police car traveling at a constant 36 kilometers per hour is passed by a speeder traveling 360 kilometers per hour. Precisely 1 second after the speeder passes, the police officer steps on the accelerator. If the police car's acceleration is 10 meters per second squared, how much time passes before the police car overtakes the speeder? So, let's kind of make sure we understand the problem graphically. So if we look at a displacement versus time graph for just a minute, there's distance, there's time, all right? The speeder, who is moving at a constant speed, that never changes, all right, passes the police officer, who is also moving at a constant speed, but a much slower speed. Okay? It takes that police officer 1 second to react. There's our 1 second. After that 1 second, the police officer begins to accelerate until he catches the speeder at this time here, which we don't know. Alright, so there's a few things that we need to take into account. We need to look at the displacement of the police officer during the reaction time, for that 1 second where he's not accelerating, as well as the distance that he travels after he begins to accelerate. Those two distances added together will equal the same displacement that the speeder has gone, and therefore we can use that information to solve for time. So, if we look, step 1 of this problem, okay, would be to determine how far the policeman has traveled during that 1 second of reaction time. So we have the equation delta x equals velocity of the police car times the reaction time. His velocity is 36 kilometers per hour, which we change to meters per second by dividing by 3.6, multiply that by 1 second, and the answer that we get is 10 meters. So he has traveled 10 meters during that reaction time. Then we have to think a little bit. The total time that the police officer travels is the reaction time plus the time that he is accelerating. We are looking for the total time, therefore we need to solve this equation for the time that he is accelerating. We do this simply by rearranging this equation and getting the following. T acceleration equals T total minus the reaction time. We plug in the value for the reaction time and we get the following expression, T total minus 1. Next, let's set up the acceleration equation for the police car. It's your favorite, the long nasty one. Delta x equals the initial t plus 1/2 at squared. Okay? The t in this case is the acceleration time, which we found to be t total minus 1. So inside that nasty equation, we're going to plug this thing to make the equation even more nasty. In addition to that, we're going to plug our numbers. Okay? Simplify this thing. Make sure that you FOIL this so that you don't make a careless error. Right? And then simplify. Once it simplifies down, we have the following. -5 plus 5t squared. Then, the total displacement for that police officer is the distance he traveled during his reaction time, which was the 10 meters found above, plus this expression here, which we plugged in, which was the -5 plus 5t squared. Simplify that, we finally get 5 plus 5t total squared for the final distance traveled total by the police car. So this is police car. Now let's look at the speeder for a minute. The speeder is the easy part. Alright, the speeder simply travels the same speed the whole time, 360 kilometers per hour, times the total time. We change that 360 kilometers per hour to meters per second. We get 100 meters per second times total time. Now, the thing to remember is the total distance traveled by the police car and the total distance traveled by the speeder are the same when they meet. Therefore, we set those two equations together. Take this value, plug it here, and this value, and plug it here. We then rearrange this thing and set it equal to 0. We get a quadratic equation. That quadratic equation is then solved using everyone's favorite, the quadratic formula. Okay? T equals negative b plus minus the square root of b squared minus 4ac all over 2a. Once we solve that, you will get two answers here. Okay, but if you look at the two answers, only one makes physical sense, because the first answer, where we did 20 minus 19.89 divided by 2, is approximately 0 seconds, which makes sense. Problem starts as the police officer sees the speeder pass him, and then he must catch up with him. So the final answer for the numbers I picked was 19.945 seconds. Hope this makes sense and helps out a lot. Let me know if there's issues.